Welcome to Science News at 6. I am your broadcaster, Timber Davis, and today we have Gabrielle Simon broadcasting live from Studio AH104. Over to you, Gabrielle.
Good evening. I am Gabrielle Simon, and here we are with Dr. Julie Woodson. And today we are talking about radioactivity.
Hi, Ms. Slayman. I'm so happy to be here today. First, I would like to tell you about the different types of radiation: alpha, beta, and gamma. First, this is a model of a visible nucleus. Let's start with what radiation is. Radiation occurs when a nuclei has too few or too many neutrons. This nucleus has too few neutrons, so it is radioactive. The first type of radiation I will show you is an alpha decay. Because the atom is radioactive, an alpha particle is ejected, while at the same time, radiation, called a gamma ray, comes out. An alpha particle consists of 2 protons and 2 neutrons. A gamma ray is basically nothing.
Well, what happens when an atom loses 4 particles?
That is a process called transmutation. We will talk about that in a minute. Alpha particles can be stopped by a thin layer of material.
What type of thin layer material? Give an example.
A piece of paper or a piece of plastic.
Okay.
Next we have a beta particle, which consists of 1 neutron. An electron is ejected because the atom is radioactive, while at the same time a gamma ray is also ejected. The difference between the alpha and beta decay, other than the electron being ejected, is that the neutron in the beta particle turns into a proton.
Wow. Then how can a beta particle be stopped?
A beta particle can be stopped by aluminum. A gamma ray can be stopped by concrete or lead. Back to the concept you brought up earlier, transmutation. When an alpha and beta decay, the element changes. The whole atomic number changes.
Okay, wow. Alright, now on to our subject, the next subject, which is fission and fusion.
So we have our diagram up there on the board. Fission happens when a neutron is being put into an atom and it hits the nucleus. Kaboom! Energy is released. Today, fission is used to make atomic bombs. Fusion is a very uncontrolled chain reaction. Fusion is still being experimented with, and its pollutants would be almost none if they can figure it out. Stars are made by fusion, and matter is converted into energy because of the high pressures and temperatures.
What a wonderful segment. I think we are out of time. So thank you so much, Dr. Woodson. And back to you, Timber.
Wasn't that interesting? Well, that's all we have for tonight. Good night, America, until tomorrow with our periodic table.